Afternoon, folks. I've got an IGCSE computer science series where we are covering hardware and software. We're going to be interested in things such as logic gates, computer architecture, the fetch execute cycle, input-output devices, memory, storage, programming languages, and translators. I hope you guys will find some of these concepts interesting. Without further ado, let's dive into the concepts themselves. All right, there we are. Pick my pen. Oh, they are saying 60 minutes, but now our interest is on hardware and software. So our objectives are to be able to identify different types of hardwares and softwares. We also look at what's the logic gates and or not, the von Neumann architecture, fetch, execute cycle, how are processes executed by the central processing unit, input-output devices, primary memory, secondary storage media. You were looking at things such as secondary storage, primary storage, well, operating systems. Which system are we using? Is it Windows? Is it Linux? We also compare the programming languages, high level, low level. High level, we're looking at languages which are human readable, but low level, that's more like instructional language, which is flexible with the computing system itself. Also look at translators and compilers, you name it. So we will look at uh, problems given below, or maybe we can start with just these basic examples to say, but can we differentiate between hardware and software? Well, hardware, that's the physical components of a computer system that we can touch, e.g., mouse, keyboard, the display itself, that's all part of hardware. But when we look at software, it's divided into two. That's application and system. When we talk of application software, we're looking at things such as Microsoft Word, Excel, PowerPoint that we use to do our typing and stuff. And when we look at system software, we are looking at operating systems like Windows, Linux, Mac, you name it. Then logic gates, there we are talking about the AND. AND is saying when we look at combinations of bits, if it's 1 and 1, that's only case where it's true. Otherwise, the other, they give you a 0. Then we have OR. OR is saying as long as we have 0 and 0, that's the only combination which gives us a 0. But the rest, they give us a 1. Then the NOT simply reverses whatever input you are given. If you are given a 0, the result is a 1. If you're given a 1, the result is a 0. Just reverses whatever input you are given. Then the components of a CPU, we have arithmetic logic unit where calculations within a computer system are performed. Control units, this one is the one which controls the instructions within the CPU. Where are we in terms of program execution? So we look at storage areas where the machine speed. So fetch execute cycle, look at it step by step. We start by the PC holding next instruction address, and then address is sent to the memory address register. Then instruction is fetched into the MDR, instruction decoded, instruction executed, then the program counter then increments to the next instruction to be executed. Then input devices example, we have for the touch screen, if you touch, the instruction is sent in. Even the microphone itself, it sends a voice into the system. So that's an example. But you were given a barcode scanner. It reads through a series of digits, and it makes sense in terms of information about price of the product, expiry date, you name it. So output, you're looking at things like the display, printouts, all that comes out of the processing of a computer. That's output. So memory types, we have got RAM and ROM. So RAM is memory that we lose after power is lost. So we call it volatile. And ROM, this is read-only memory. So it's not erasable. We don't lose it when power goes off. High level versus low level languages. High level, like we were saying, this is more human readable, like Python, Java, JavaScript, HTML, you name them, all those that one can properly follow as you read the instructions. Then low level, this is assembly or hardware specific. Here we are interested in maybe hexadecimal communication stuff, which is more readable to machines themselves. Right, so here we are. First, we want to define hardware and software. So as we had earlier, hardware, these are the physical computer components. Um, then when we talk of software, these are intangible. In other words, we can't touch intangible components of a computer system. So we can just feel their presence by changes which happen, so intangible components of a computer system. Now, the next problem, we are required to draw the symbols for AND, OR, and NOT. So I'll start with AND. AND, we have got a vertical bar there, and we have input lines A, B, then output, we can call it X. If I go to OR is similar to AND, but it has got a curved line instead of the vertical bar. I've got A, B, and the output there, we can call it X. Then the not something of this sort. So there is A, because it's not, we'll put a circle here. Then we have X, but our X there is going to be A bar. Otherwise, we're just reversing. Then the next problem there, we want to fill in a truth table for an AND get. AND get. So I've got A, as my input lines A, B. So this is AND. So I want 4 combinations, then my output. So here I have 0, 1, 0, 1. So here is 0, 0, 1, 1. And with AND, we said it's only true when, when both inputs are 1. So let me properly write it. Here we have 1, the rest are zeros. That's the truth table for the AND. Explain the difference between RAM and ROM. So the major difference, RAM is volatile. In other words, we volatile. In other words, we lose the contents when power goes off. And with ROM, can simply say this is non-volatile. Right. Describe what the program counter does. I mean, this one is uh, stores the address of the next instruction to be executed. Right. What is meant by the fetch execute cycle? Um, so fetch execute cycle, these are a series of steps followed as CPU processes instruction. So we look at what's to be executed next, where our program counter is, memory data register, all those things, we have them in mind. Now, give 2 examples of input devices and their uses. So 2 examples of input devices, we spoke about a microphone, and this one, it captures voice. So it's voice input into the computer system. Then we can talk of a scanner or scanner. Is what it can be taken as an OCR, that's optical character reader. It reads what's on paper and convert it into digital format. Then give 2 examples of output devices and their uses. We can talk of opposite to microphone. We have a speaker. So this is sound output. Then a printer itself prints out data on paper. State one advantage of solid state drives over hard disk drives. So one advantage is they are fast because they don't have rotatory components, because there are no rotatory components. Right. Then the last one, describe the difference between compiler and interpreter. So with a compiler, program is converted or compiled after the entire file is developed or code. Then with interpreter, we are saying errors are checked line by line, such that if there is an error, it will be picked or identified there and then before the whole code is developed. Thank you.